I welcome you to this class of econometric methods. Myself, Dr. Muhammad Imdadul Haq, an associate professor at the Department of Economics, Aligarh Muslim University. The discussion in today's lecture is on time series econometrics. Basically, this is an introductory lecture. We will go through the importance of time series and go through the development. This is not a very old field, but we will go through the recent developments which we had. Not the recent, but how this came into emergence. Imagine that you are having a data set. You want to establish a type of causal relationship between the variables. You have taken a data set for say 2 to 3 years, and then you do the regression. You apply our classical linear regression method. We apply the method of OLS, ordinary least squares. We get the results, we get the value for beta hat, we get the value for alpha hat. You check for the problems of heteroscedasticity, serial correlation, and if it's a multiple regression, you also check for multicollinearity. And we check everything is fine. Even if everything is fine in such a case, and we have not checked for this particular issue. That is why I would refer it to be as the biggest issue. If we have not checked for the stationarity of the data and we have simply gone for doing the regression, you cannot make meaningful interpretations. You cannot depend upon the results. Your results may be technically spurious, nonsensical. So, although this stationarity is not one of the assumptions of classical linear regression model, but this development in the field of econometrics has as such revolutionized the procedure of estimation of parameters. Meaning thereby, you do OLS, everything, all the assumptions are fulfilled. But if there is an issue with the stationarity matter, or if I make it more clear, if your variables are stationary at first difference, then you cannot use the results of your regression. If your data is stationary at level, although we will look at it at detail, understand what is the stationary at level and stationary at first difference in a quick sense. Suppose we have time over here. Suppose we have time. Suppose you have your time period, say 1, 2, 3, 4, 5. And you have whatever data you take, 5, 7, 15, 30, 50. You have let it anything, say 5, 10, let it be anything, a data like this. Now, if this data is stationary, if this series is stationary and there is another series that is also stationary, fine, you can do OLS. This is, I'm just referring to at the moment time. But say if this data is not stationary and you are doing OLS, then you cannot estimate the parameters based on that. It means now it is stationary at first difference. Like we will see, if it is stationary at first difference, then what does this mean? Simply you take a lag in it, like this is xt, you take a lag in it, like this 5 comes over here, this 10 comes over here, this 15 comes over here, and this 30 comes over here. So we have a variable xt minus 1. There is an x, this is 5, and this is 5, this is 15, and this is 20. Now if this is stationary, then we say this is stationary at first difference, or this is stationary. This is called as I1. We will see to it in detail. But so this is not one of the assumptions of classical linear regression model. Nevertheless, it's a very important issue, and if the matter of concern, stationarity, has not been addressed and you are going on with the estimation, you are going to fall into problems. Most of the time series like GDP, GNP, export, they exhibit a tendency to increase over time, which could not be explained as a random deviation from an underlying deterministic trend. The basic purpose is, now you have to make yourself habituated to words like deterministic trend, stochastic trend, or so there is one thing. I'm introducing you, I'm not explaining to you at the moment, I'm just introducing to you that there is something called as deterministic trend. Then rather the trend itself shows some changes, that the trend itself is a stochastic, perhaps a steep increase at one time and a slow increase at one time. So trend, it can be deterministic, it can be stochastic. We will see to it what is the meaning of stochastic. And so what are the issues? What we meant is, because of stationarity, there can be issues with the regression. A regression of yt on xt is meaningful only if both the series are trended. If one series is trended, the other series must also be trended. Only then that result is meaningful. Only then that result is sensical. Now, what was the traditional solutions before the incorporation of time series econometrics? The traditional solutions were detrending the series. What you do, you simply detrend the series or introduce time as a dummy variable. Detrending the series, it's just you take xt and you regress it on time. You take the variable, you regress it on time, you get a set of residuals, and then you regress the detrended yt series on the detrended xt series. So this is the traditional method of catering to this need. Also, you can introduce a time dummy variable. You can introduce a dummy variable in the time, and a trend, you can get that element of time from there. But both these methods assume that the trend is deterministic. Trend is deterministic, meaning thereby if the trend is removed, we will get a stationary series. Such a process is called as trend stationary. In a layman terms, stationary means that the data is just of this, it is having a same flow. But in economics, even if there is no production in the economy, even if there is no export, still the GDP will increase. Why? Because one of the components of GDP is consumption. Population will increase. Obviously, all our mortality rates have decreased worldwide. So obviously, the birth rate is higher than the death rate. So when more people are born, they tend to consume. When they will consume, it forms a part of the GDP. So there will be a trend. Now, if my data is moving along the trend, fine, it is a deterministic trend. If this is the case, what we say, if we can remove the element of trend, like we have seen the two methods, either you use a dummy variable to remove it, or you detrend the series. If you detrend this, you remove the trend, you get only the stationarity element of the data as such. So if this is the process, okay, very good. These two methods, the traditional time series methods, you will find that these two methods are very well suited for getting the estimates of the parameter. And based on this, see, if you refer to any book of statistics, or even particularly a traditional book of statistics, you will find a chapter on time series. And you move to a book of econometrics or time series econometrics, you will find those two are completely different. Something else is being taught in, because see, that something else is being taught in that book of statistics and something else is being taught in the book of econometrics. The difference is that in the statistics, they are assuming that the trend is deterministic. If the trend is deterministic, the traditional methods which we can do and apply, and you have the time series decomposition, you have the moving average, you have the exponential smoothing methods, these all things can be applied and you can interpret the data. You can get meaningful interpretations from the data. You can get the coefficients, you can get the estimate the parameters. But is it always the case like this? Okay, so the first thing which you should understand is what is a deterministic trend and what is the opposite of it. That is the word stochastic trend. Stochastic is nothing but random. So, in deterministic trend, the effect of the shock disappears. You are moving, there is a shock, say a positive shock, you increase, then slowly the effect fades away and you come back to your original situation. You are going, there was a negative shock, you came down. In the time of COVID, your GDP came down, but after a span of 2-3 years, again we are on the same track on which we were before the coming of COVID. So it means the shock is not integrated into the system, rather the shock disappears. Or you come back to the mean. That is why they say the word mean revert. If a series is having the characteristic of mean reversion, they were moving, you come back to the mean. I came down, you come back to the mean. It is deterministic trend, or it's a different type of non-stationary. What is the other way? The effect of the shock is integrated into the system. Before 1991, our foreign exchange reserves were very less than 100 million. Now, so we were moving like this, but with the reform process, now our foreign exchange it has not come back again to the initial, like to the same level which we were before 1991. It has gone, it is increasing and increasing and increasing. So the shock is integrated into the system. This process is non-stationary. If the effect of the shock is as such, it has an element of permanency in it, it is what you refer to as that there is an integration into the series. Mean of the series, here the mean of the series is not an estimator of mu. We will see to these things, the technical things at a later stage, but just you have to understand what I am trying to emphasize is there are two types of trend. One is deterministic, fine, you can work with it even using the traditional tool of statistics. But if the trend is stochastic, if the effect of shock is integrated into it and it is not mean reverting, then in that case you cannot use the methods of traditional econometrics or even traditional statistics. We can have a quick look at stationarity. What is a stationarity? Mean and variance are constant over time, and covariance between two values depend on the length of the time separating these values and does not depend on the actual time at which the values are observed. We will in our coming classes in depth deal with this. But at the moment, if just for the sake of understanding, means although it's a very naive type of method to explain, is that if the series is just going on, no, it's just like a stationary. If suppose this, you can call it a stationary. Series X is a stationary, series Y is not a stationary. Basically, there are three characteristics of a stationary: mean constant, variance constant, and covariance does not depend upon time. I will restrict myself at the moment. I will not go again into the detail of stationarity at the moment. We will go, but at the moment, just in today's lecture, I am trying to introduce you the terms. Again, stationarity is of two types. One is weak, and the other one, the opposite, is strong stationarity. In econometrics, we do not deal with strong stationarity. We only deal with weak stationarity, or what you call it, covariance stationarity, or second order stationarity, or wide sense stationarity. So these are all the same terms. Only thing is, we do not refer to strict sense stationarity when we refer to stationarity in the in econometrics. We do not refer to that.